All right, this is chapter 10, and we are looking at conic sections. Basically, what all of the different shapes we are going to be looking at graphing in this chapter are if you were to take a double cone, that's what this is here, a double cone, and cut it by a plane. So the first conic section we'll be looking at is the ellipse. And if we take a plane, if you think of like a sheet of paper cutting this cone, the shape that will be made would be like an oval, an ellipse. If we were to cut it perfectly parallel to the base or bases, then that would give us a circle. If we were to cut it vertically through the bases, then that would give us what's called a hyperbola. And then if you were to cut it vertically at a diagonal, we would end up with a parabola. Okay, so those are the four conic sections, and these are what their graphs look like. We actually covered circles back in the first unit of the semester. Those ones are pretty basic. The equation for a circle is just x minus h squared plus y minus k squared equals r squared. And we graphed those a while back. So the other conic sections we're going to be looking at in this chapter, starting with the ellipse, and you can see the not ideal form of each of these equations listed below here. I'll show you on the next page what the ellipse, the standard form of the equation of an ellipse looks like. And we have both horizontal and vertical ellipses. So we have x minus h. H will always be with x no matter what conic section we're looking at, and k will always be with y. The center is hk. And if the larger value, the a value, is underneath the x, that means it's a horizontal ellipse. If the smaller value, the b value, is underneath the y, then that tells us, again, it's horizontal. So whichever variable the larger number is underneath tells you whether it's horizontal or vertical. That is only for the ellipse. That is not true for the hyperbola, which we will see in the next video. So this the way you can tell, again, is the a value, whichever variable is underneath. The larger value tells you whether it's vertical or horizontal. So whether you have a horizontal or vertical ellipse, we have the center of the ellipse. And then if it's a horizontal ellipse, you go out horizontally the amount a. So the formula has a squared. If that's like 25, then your a value is 5. You go out to the side 5, to the other side 5. And then whatever your b value is tells you your co-vertices. So those give us our vertices. And then our co-vertices are going out that smaller number. So let's say b squared is 9. Then your b value would be 3. You'd go up 3 and down 3, and that would give you your ellipse. Now, ellipses also have what are called the foci, or the focus. There's 2 of them. And those go out a distance of c on the major axis. So if this is a horizontal ellipse, this is the major axis. If it's a vertical ellipse, this is the major axis. So whatever type of ellipse it is tells you where your foci are going to be. If they're going to be horizontal, if you are doing a horizontal ellipse, your foci will be vertical if they are, or if it's a vertical ellipse. And again, that distance is c, which we can find from a squared minus b squared. So that'll tell us our c squared value. So looking at our first couple examples here, it says, what is the standard form for the equation of an ellipse with vertices at plus or minus 8 and foci at plus or minus 5, 0. So even though it didn't tell us to plot those points, it's really helpful to visualize it. So positive 8, 0 would be out 1, 2, 3, 4, 5, 6, 7, 8, 0. And then negative 8, 0. And if those are my vertices and they are horizontal, I know that this is a horizontal ellipse. So I know I'm trying to fit this into the form x minus h squared over a squared. And it's horizontal, so the bigger value underneath the x. And then plus y minus k squared over b squared equals 1. Well, halfway between my vertices is going to be my center. And if this is negative 8 and this is positive 8, halfway between is 0, 0. So my h is 0 and my k is 0. Okay, so that's my center, 0, 0. So it's my center. This is my vertice. This is another vertice. And they also tell me that my foci are at positive, negative, 5, 0. So 5, 0, and negative 5, 0. So those are my foci. And if my foci, again, are on this axis, that means this is a horizontal ellipse. So my C value then is 5, and my A value is 8, and I can find my B value using A squared minus B squared is equal to C squared. So I already know A squared is 8 squared, so 64. I don't know B squared yet, and I know H and K. So this is the last piece that I need. So C squared equals A squared minus B squared. So 64 minus B squared equals 25. Subtracting 64, we end up with negative 39 equals negative B squared. So B squared equals 39. And I actually don't need to find B. I need B squared. So my answer then, H is 0, so I can just write x squared over 64 plus y squared, because k is also 0, over 39 equals 1, is the equation of my ellipse. All right, the next example says, what is the standard form of the equation of an ellipse that has vertices at negative 2, negative 8, and this should say negative 2, negative 8, and negative 2, positive 2. So go ahead and change that one to positive 2. And then foci at negative 2, negative 7, and negative 2, 1. So I have negative 2, 2. That's right here. And negative 2, negative 8, and that is right here. So if those are my vertices, then I know this is a vertical ellipse. So x minus h squared over b squared plus y minus k squared over a squared. The larger value is going to be underneath the y because it's a vertical ellipse, equals 1. Now, before I even go any further, I can find my center. If this is up at positive 2 and this is negative 8, halfway in between there would be negative 4. And that's going to be my center. So, oh, you know what? Not negative 4, negative 3. A little bit higher. So I have that point there as my center. So that would be negative 2, negative 3 is my center. So that tells me my H and K. And the distance from the center to my vertices is my A value, and that distance is 5. Okay. And so the only thing left to find is my B value. I was told that my foci were at negative 2, negative 7, and negative 2, 1. And those are my foci. And so that C value distance is going to be 4. So I can go ahead and use my formula. A squared minus B squared equals C squared. And A is 25. I don't know B squared, but I know that C is 4, so C squared is 16. Subtracting 25, negative B squared equals negative 9, so B squared equals 9. And so I can go ahead and write my equation. H is negative 2, so that'll be x plus 2 squared over my b squared, which is 9, plus y, and then my k is negative 3, so this will be plus 3, and then that's squared, and then over 25, my a squared value. Remember, a is 5, the distance from the center to the vertices, and then equal to 1. And so that is the equation of this ellipse. All right, on the next page, we are going to practice graphing some ellipses. So here I have the equation x squared over 9 and y squared over 25. Since the bigger number is under the y squared, I already know this is going to be a vertical ellipse. And since there's no value on the x or y, I know my center is 0, 0. So A is equal to 5 and B is equal to 3. So from 0, 0, I know this is vertical, so I'm going to go up 1, 2, 3, 4, 5 for my, and down 5 for my vertices. So that would be at 0, 5, and 0, negative 5. And then out 3 to each side for my co-vertices. So that would be 3, 0, and negative 3, 0. And that allows me to draw my graph. And then my foci is c squared is equal to a squared minus b squared. So 25 minus 9. So c squared equals 16. So c equals 4. And so my foci are on that major axis. If this is a vertical ellipse, they're going to be out 4 in each direction on that major axis. So that would be 0, 4, and 0, negative 4. All right. So the next example, we are given the equation, but it is not quite in standard form. Normally they are set equal to 0, and so, or not equal to 0, equal to 1. So I need to divide by 100 everywhere. So I'm going to divide by 100. And 4 and 100 reduce to x squared over 25. And 25 and 100 reduce to y squared over 4. And then 100 over 100 becomes 1. So I have um, my a squared underneath the x. So I know this is going to be a horizontal ellipse. And again, there's nothing on my x or my y. So my center is 0, 0. And so center 0, 0, my A value is 5 and my B value is 2. So out horizontally 5 and 2, 4, 5, and vertically 2 and 2. And that gives me the shape of my ellipse. And now I need to find my C value. So c squared is equal to a squared minus b squared. So 25 minus 4, so 21 is c squared. So c equals the square root of 21. Now the way I want you to write your foci when you don't have a whole number there is we're going out square root 21 and out square root 21. So you can write square root 21 comma 0 and negative square root 21 comma 0. Or you can write plus or minus root 21 comma 0 to combine them. Either way is fine with me. So the next one, when we look at the equation, we can see that the center is not at the origin. Looking at the equation, my h is negative 2 and my k is 5. So negative 2, 5 is my center. And I can tell this is going to be a vertical ellipse because the larger number is underneath the y. So I have negative 2 up 5, and that is my center. And then I know it's a vertical ellipse, so I'm going to be going up 1, 2, 3, and down 1, 2, 3 for my vertices. And my co-vertices, so A equals 3 and B equals 2, out 2 to each side. Before I go any further, I'm going to go ahead and write those points. My vertices were at negative 2, 2, and negative 2, this was 5, plus 3 would be 8. And then my co-vertices were at 0, 5, and not 0. This is negative 2, negative 4, 5. I need to find my foci. C squared is equal to a squared, which is 9, minus b squared, which is 4. So c equals the square root of 5. 9 minus 4 is 5, so c is the square root of 5. So I would be, let me go ahead and just draw my ellipse here. I would be going up the square root of 5, which is a little bit more than 2, and down the square root of 5, and those are my foci. And the way I can write my points here is going to be the 2 is my x value is the same for both of those. So 2 and my y value is what's changing. So from a y value of 5, I'm adding root 5 and subtracting root 5. So that would be 5 plus root 5 minus root 5 plus or minus root 5. And that's how I can write my foci. And this is actually -2 there. And there are all the pieces that I needed to find. One more example. So this equation is not in standard form. It says write the given ellipse in standard form, label the vertices, center, co-vertices, and foci. So I'm going to just make that list off to the side here. Center, vertices, co-vertices, and foci. And I need to find all of those pieces. But what I'm going to have to do is completing the square 2 times in this problem. So I'm going to keep the x's grouped together and the y's grouped together, and I'm going to color code this whole thing. So I have 4x squared minus 40x, and I'm going to be adding something to complete the square, plus 9y squared plus 36y plus something to complete the square, and then equal to subtracting 100 to the other side. And whatever I add to one side, I also have to add to the other. All right, let me zoom out a tad here. So when we are completing the square, we want our a value to be 1. Right now it's 4. So I'm going to pull the 4 out, and I'm left with x squared minus 10x plus something, and then plus 9 and y plus 4y plus something. And then what I'm really adding to the other side is 4 times what I put in the box and 9 times what I put in the purple box. So what's going to go in this box here is my b value divided by 2 squared. So -10 divided by 2 is -5 squared is 25. And here, 4 divided by 2 is 2, squared is 4. And so that's what's going in those boxes. So this can now be written in factored form, 4x minus b divided by 2, which is 5. So since it's a -10, it stays negative. So -10, this becomes -5 squared. And then plus 9, and then y and b divided by 2 is 2 squared. Again, it keeps the sign. If it's a plus, it stays a plus. If it's a minus, it stays a minus. And then equal to -100. 4 times 25 is 100, so -100 plus 100, those cancel out. And then 9 times 4 is 36. We're almost in standard form for the ellipse. I can divide both sides by 36. And 4 and 36 reduced to 9, and 9 and 36 reduced to 4. So this becomes x minus 5 squared over 9 plus y plus 2 squared over 4 equals 1. So now I can find all of my pieces here. My center is at 5, -2. And then my vertices from that center, let me use this space up here to kind of help draw this out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So my center is at 1, 2, 3, 4, 5, -2. My vertices, since this is a horizontal ellipse, I'm going out 3 to each side. So 1, 2, 3, and 1, 2, 3. So my vertices are at 8, -2, and 2, -2. And then my co-vertices, my b value is 2, so I'd be going up 2 and down 2. So that would give me 5, 0, and 5, -4. And then my c value, c squared is equal to 9 minus 4, so c is equal to the square root of 5. So like we did before, my x value now is going to be at positive 5 here, and then I'm going to the right root 5 and to the left root 5 since this is a horizontal ellipse. So my x value is 5 plus or minus square root 5, and my y value stays -2 that whole time. And that is the last example of ellipses and the end of section 1.